We are to find the local extrema of the function f of x equals cosine 2x plus the square root of 3 sine 2x on the interval from 0 to pi and say where they occur. So the first thing that we'll need to do is find the first derivative of the function f of x equal to cosine 2x plus the square root of 3 sine 2x. The first derivative will be negative 2 sine 2x plus 2 times the square root of 3 cosine 2x. Now we will need to set this equal to 0 to find where the critical points are. So minus 2 sine 2x plus 2 square root of 3 cosine 2x equals 0. We could add 2 sine 2x to both sides, and we would end up with 2 times the square root of 3 cosine 2x equal to 2 sine 2x. Now, dividing both sides by 2 cosine 2x would leave us with square root of 3 equal to tangent 2x. If we think about our special triangle, where we have a right angle, pi over 6, and pi over 3, and the sides are 1, 2, and square root of 3, the tangent opposite over adjacent is equal to the square root of 3 at pi over 3. So let's look at a unit circle. We have found that the angle pi over 3 is where the tangent function is equal to the square root of 3. However, our equation says that the tangent of 2x, not x, is equal to the square root of 3. So we will need to find out where the angle x actually is. So we will set 2x equal to pi over 3, multiply both sides by 1/2, and we'll find that x is equal to pi over 6. Let's see if there are any other angles on the interval from 0 to pi where the tangent is equal to the square root of 3. In the third quadrant, there is an angle 4 pi over 3 where the tangent is equal to the square root of 3. So now, if we set 2x equal to 4 pi over 3, and again multiply both sides by 1/2 to get x by itself, we will find another angle then, x equal to 2 pi over 3, on the interval from 0 to pi, where our first derivative would be equal to 0. So we have these two angles, pi over 6 and 2 pi over 3. Let's look at the graph of the function cosine 2x plus the square root of 3 times the sine of 2x in order to see this. On this graph, we can see that at pi over 6, we have a local maximum, and at 2 pi over 3, we have a local minimum. Where they occur would be the y value of the function at those points. Looking at the graph, it looks like it's 2 and negative 2, but we can plug our values, pi over 6 and 2 pi over 3, into our function, f of pi over 6, and verify that. F of 2 pi over 3 is equal to negative 2. The B part says to graph the function and its derivative together and comment on the behavior of f in relation to the signs and values of f prime. Here we have the function f in red and the derivative f prime x in blue. Our relative extrema points are the point pi over 6, 2, and the point 2 pi over 3, negative 2. And we can see that the first derivative is 0 for these values of x. We might also note that on this particular interval from 0 to pi, the function f is increasing from 0 to pi over 6, and at the same time, the derivative is positive. The derivative is positive yet decreasing, which agrees with the fact that the slopes of the tangent lines on the function f are decreasing until we find a horizontal tangent line at x equal to pi over 6. Continuing along, the function f is decreasing all the way until we get to 2 pi over 3, and correspondingly, the values of the y coordinates on the derivative are negative until we get to the point 2 pi over 3 where they're 0 again. Then the function f increases all the way to pi, and the values of the first derivative are positive all the way to pi.